Hello guys, welcome aboard. My name is Tadeu Barbosa. I am software engineer at CBDS, a Brazilian software development company. In this video, I will present how to implement asynchronous communication in a microservices architecture. So, let's get started. This is our disclaimer. Nothing very interesting. Let's go to the next slide. Before we begin to analyze the implementation, it is important to know a little better the concepts and the main components that consist the asynchronous communication using messaging. As you can see, the messaging mechanism is basically composed of three participants. The first is the producer. It is responsible to send the message to the broker. The second is the consumer. It is responsible to consume the message. And between these two participants, we have the third, the infrastructure that we usually call the broker. There are several implementations of brokers on the market. In our example, we use Apache Kafka. There are others as readme.pdf, MK series, and so on. The most important thing in understanding the messages service is to understand that the producer is responsible for creating the message and send this message to a queue. The messaging service is responsible for receiving this message and delivery to the consumer. The consumer is responsible for receiving this message and process it. In the world of messaging, we basically have two main models. The first we call point-to-point, and the second we call publish-subscribe. The difference between one and the other is in the number of consumers that our message will have. When we choose a point-to-point model, we guarantee that the message will be consumed by one and only one consumer. The publish-subscribe model, the message will be consumed by several consumers who have been listening to that particular topic. Each message basically consists of two pieces of information. The header, where we store the relevant message information in the key value pair, and the message body. The message body is where we will write the content of the message to the consumer. Basically, we have three different types of message. The first is the document. It is a generic message where it contains only data, and the consumer will decide how to interpret this data. The second type of message we have is a command, where the message is equivalent to an RPC request. It specifies the operation you want to perform on the consumer and the parameters you would like to pass to this call. The third type of message we have is a message we call events, and normally these events are associated with state changes that you want to notify other participants. Usually domain objects are a good example of events. On this slide, we can highlight some benefits and some drawbacks that we may have with messaging service. Some benefits we have a low couple between the participants, a guarantee of delivery, and the flexibility of communication. Some drawbacks that we have with the broker can be a bottleneck of our architecture. The broker can be a single point of failure, so it is essential that the broker has high availability for production environment, and of course, as we have a new participant in the architecture, this implies complexity in general. On this slide, we have the example of the implementation that we will see in the next section. Service A needs information that is in Service B. One way to implement it is to communicate synchronously Service A with Service B. For any request, Service A will invoke Service B to get the information. We can improve this implementation by introducing the concepts of asynchronous messaging and communication. We can introduce a cache mechanism in Service A. In this way, service A will store the information it queries from service B in a cache, and once service B changes any object state, it will create a message and will send to the broker this message. And then the consumer will consume this message and consequently update his cache. With this mechanism, service A must always check your cache first. If it contains the object, so get the objects from the cache. If it does not contain, then makes a call to service B. With this approach, we reduce the number of synchronous communication in our application, and we guarantee also that our cache will always be updated with the latest information from service B. Another important point to highlight in relation to synchronous versus asynchronous communication is that synchronous communication reduces the availability of our application. As you can see on the slide, imagine that each service has a 99.5% availability. To calculate the overall availability of all these calls, we take the power of 3 this number, 99.5, which results in a number of 98.5 of general availability of our use case, something much smaller than the initial 99.5. So, the way we have to increase the availability of our application is avoid unnecessary synchronous communication, is to introduce asynchronous communication and messaging services. In this way, we are able to increase the availability of the application as a whole. Past a little about the main concepts of the messaging service in the context of microservice architecture, let's see about the implementation. Let's see how to implement this in a Java application using the Spring framework. More specifically, the Spring Cloud Stream enable the construction of this type of architecture. The Spring Cloud Stream is an annotation-based library in which it abstracts much of the complexity, making it easy for the programmers to build this kind of implementation. Here we have the main flow of how the Spring Cloud Stream works. Basically, we need first of all to identify who is the producer and who is the consumer. We use the term source to refer a producer and sink to refer a consumer. In both participants, we have the same structure, like a chain of classes. We have the most low-level classes that are the binders. These classes are responsible to interact with the broker. We have a class called channel that is an abstraction of broker queue, and at the top of all, we have the source and sink class. The flow of construction is: the producer creates a message, send this message to the broker. The broker is responsible to deliver the message to the consumer, and the consumer will process this message. Now, we need to configure and implement a few steps in order to create a producer. First, we need to add 2 dependencies at the POM.xml file. We also need to insert an annotation at enable binding at the bootstrapping class. Look that we have used the source.class to binding the producer. Let's suppose that we want to save a specific object and notify other services that his object was changed. In the save organization method, you can see at second line something like save this object at the database. After this, we call the method publish organization change. This method is responsible to create and send a message to the broker. We pass 2 arguments to this method. The first, a string with the operation that we did, and the second, the identifier of this object. Now, let's analyze the publish organization change method in more detail. This method takes the 2 parameters and create an object called organization change model. In the simple source being class, we define an attribute called source. and this attribute is responsible to obtain the output and consequently send the message to the broker. We pass to with payload method the object that we want to send. Here we have some configurations that we needed to do in order to run our producer with the broker. Look that we have some properties that are some obvious, like the last two. These parameters tell to Spring where the broker is located, in this case at localhost. Other important parameter is the destination. In this case we set to product event topic. This is the name of the topic in the Apache Kafka. In the same way that we needed to configure and implement some key points in the producer, we needed to do at the consumer. We can start with the libraries and dependencies. Here we have the same two dependencies that we use at the producer. We needed to insert this dependency at the POM.xml file. To implement a consumer, we needed to use two annotations. The first, enable binding. We set this annotation with the sync class. When we use the sync class with enable binding, it means that we are referencing a consumer. The other annotation is stream listener. We use this annotation on the method that will be the consumer of the message. The Apache Kafka will deliver the message to this logger sync method. Look that the argument of logger sync method is the object organization change model that is the same type we sent in the producer. Now, in the implementation of this method, we can process our received message. Like that producer, we needed to configure some variables in order for the consumer to work properly. The configuration is almost the same thing that the producer. The change is the name of the parameters. On the consumer side, if you look at the name of the properties, we do not use output at the name. Instead of, we use input, but the values of the parameters in this case are the same. Now, let's go to the Eclipse and see this example running. Hi guys, let's see our example running. So I already start the Zookeeper and I already started the Apache Kafka. I wrote the step-by-step how to install and running these two softwares. It is a prerequisite in order to run our example. So what we have here, we have three projects: Eureka Server, Order Service, and Product Service. These three projects are Maven projects, so you need to import these projects like this existing Maven project. So this project is available in a Git repository that the URL is it is the description of this video. What we have, the Eureka Server is our service discovery. It's a very simple project that acts like a service discovery. We have one service called Order Service and the Order Service called Product Service. Okay, so what is the main part of the Order Service is these two methods. This method creates an order. The order is composed with order lines, and what we did, we try to use a very simple cache, and we try to base it on the product ID. We try to get this information in the cache. If this product is not present in the cache, so we go to the product service and get the product. Okay, just to see the implementation of the cache is just a hash map, like with an integer ID and the product. So the product that gets the product from the cache receive an ID, and if the product is not present, I log this information. If the product is present, I log cache hit for key, a specific key. And this method is responsible to put a specific product to the cache. Okay, and this method get the product from service. They do a REST call to the product service. Okay, so let's go to running all participants. First, I will run our service discovery. Okay, the service discovery is up and running. Port 8761. Okay, if we go to this, okay, no instance current registered in the Eureka server. So let's go to start our services, the order service, running. Okay, and the product. Sometimes you need to wait a couple seconds to see these services available at the service discovery. So refresh this page, and when you see these two services, okay, they are available in our Eureka server. Perfect. So let's go back to the Eclipse. Now, if you see our product information, let's to explain this part. I have did a mock, like a pre-defined the products. So ID number 1, we have value of 10, ID number 2, 20, and so on. So when we go to the Postman and ask to order service create one product number 1 with 2 quantities and one product number 2 with 1 quantity, the result is 40. Okay, so let's go to see our log information. If you see these lines, cache miss for key 1, cache miss for key 2. Okay, so these two IDs are not present in this cache. After we get this information, so the order service input this information in the cache. Perfect. So if you send again the same request, the log now hit these two IDs from the cache hit for number 1 and cache hit for key 2. What happens if I change a value in the product service? So now I am updated the ID number 2 to price 5. Original, the price of the ID 2 is 20. So if you send, okay, and in our log you can see that our order service receive an information about the event message and updated our cache. Perfect. So you can see this here. In order service class, you can see a stream listener, and here we consumer a product event. And now this product, we updated the cache and the information about the updated the cache. So now if we send the same order line list to the order service, as you can see, we have an updated price. So they get the correct value about the ID number 2. So our cache is consistency. Our cache was refreshed and now it is consistent. And you can see in the logs of Apache Kafka this the consumer and the producing about this message. So this is our example. I hope that you enjoy our video. Thank you so much, and please subscribe our channel. Okay? See you on next video. Bye bye.